Welcome to the Fireside Chat, the official podcast of Firepoint Energy. Here are your hosts, Bill Smith and Ian Douglas. This is Firepoint Energy Chief Communications Officer Ian Douglas, joined as usual by Firepoint Energy CEO Bill Smith. Bill, how's it going?
Good. How you doing, Ian?
Doing wonderfully. Okay, so today we're going to talk about gas-to-liquid systems and the gas-to-liquids process. At Firepoint Energy, we talk about plasma gasification like it's the star of our process, which involves converting waste coal into sustainable aviation fuel and extracting rare earth elements from it. Obviously, plasma gasification is a huge part of what we do, but it's really just the first piece of the puzzle. So, Bill, what is a gas-to-liquid system?
Back in the early 2000s, there was a lot of talk about ethanol, E85, and converting corn into ethanol to add to gasoline at an 85 to 15% ratio. And I figured, well, it won't be long. People start screaming about using food for fuel, which that's what killed the ethanol industry to some degree, along with the petroleum industry wanting it out of the way because they weren't selling fuel. I.e., I had an office in Thailand, and the king of Thailand said, okay, I want E85. I want E10 this year. And then I want E15. In the third year, I want E85. And I said, here's what's going to happen. First year, they're going to ignore you. This is a kingdom. The second year, the guy that works at EP, BP, and Exxon and some other companies has got to go to the boss and say, listen, hey, we're going to lose 15% of our sales. No big deal. But next year, we're going to lose 85% of our sales. And I said, they're going to kick back and say, ethanol is going to do this to your car. Ethanol is this bad, and blah, 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 blah. Even though we used to use ethanol back in the 80s, and it was called gasohol. So long story short, I had this crazy chemist working for me, Rod Hoffman. And Rod and I were talking about, can we make a synthetic fuel? And long story short, I started researching, and I found that from 1920s to 1940s, Germany used what's called a Fischer-Tropsch system because the two guys that invented it. They would take lignite coal, which is the worst grade of coal. They turned it into a gas with a gasifier. They turned that gas into synthetic fuel. And the way they did that was the gas went into, in a sense, a big pressure cooker. In the pressure cooker were a lot of catalysts. And the catalyst caused a chemical reaction to take place where the gas got converted into, at that time, a synthetic crude oil. And then they would take the synthetic crude oil and do what we do in the petroleum industry today. That technology came to the U.S. in 1940s after the war. And long story short, the oil industry decided they didn't want it because petroleum was cheaper in their mind. So synthetic fuels kind of disappeared for decades. Never went away, just kind of became quiet. Until recently, it started resurfacing. So the other thing that's happened along the way is the catalysts that cause the reaction of the gas to be converted to a synthetic fuel have improved greatly. Halder Topsoe, for example, makes a catalyst that we intend to use in this gas-to-liquids plant we'll buy from a company in Oklahoma. And in the first pass, 80% of that gas is converted into jet fuel. I mean, jet fuel, like take it out, dump it in a jet engine, go flying kind of fuel. The last 20% can be thermally upticked back into jet fuel, or we can make gasolines, diesel fuels, ethanol, methanols from it if we want to change the process. So synthetic fuels, I believe, are going to be the next wave of fuels because synthetic gasoline in your car will never know the difference. Synthetic diesel fuel in your truck will never know the difference. Synthetic jet fuel in aircraft will never know the difference. The only difference is the emissions will be either carbon neutral or carbon negative, which means they won't be dirtying up the air the way petroleum does. Because in our case, we use waste streams that were cleaning up the garbage, the landfills, the waste coal piles and such, to eliminate them and at the same time produce a fuel to offset petroleum fuels. So they've been proven to run from 50 to 97% cleaner than petroleum-based fuels.
So now on the back end of the gas to liquids process, we are creating sustainable aviation fuel But correct me if I'm wrong, there are other fuels that we could be creating through this process. So what is it that determines the sort of fuel that's emerging from the gas to liquid system once the process has run its course?
So the catalyst from the 1920s to the 1940s was mostly an iron oxide and a cobalt. And that produced a fairly chemically close to diesel fuel. And that could be thermally reformed into jet fuels, gasolines, and so on. Today, the catalysts range from iron oxides to cobalt, exotic metals, zeolites in some cases. I'm building another catalyst here, copper. These different metals and minerals cause different chemical reactions. So the equipment stays the same. We change catalysts to change fuels. And you're asking what kind of fuel we make. If we put in one type of catalyst, which we're after mostly jet fuel because it pays the most, we can get from $4 to $11 a gallon for jet fuel. But change the catalyst, we can get diesel fuel, we can get gasoline, we can get methanol, and we can get ethanol. For ethanol, we use one compound called copper metaphosphate. And these compounds cause the molecular change to produce a different fuel. So think about a pressure cooker and you put your different sauces in it. If you add more salt or whatever, the outcome's always different. So we just change catalyst to change a fuel.
And with Firepoint Energy focusing on sustainable aviation fuel, it sounds like you could use a gas to liquid system to make just about any fuel that there's a demand for. Is that correct?
The answer is yes. I was kind of alluding to if we use a copper compound, we can produce ethanol. So instead of using corn to make ethanol, we can use garbage to make the gas, to use a catalyst to make ethanol. Change the catalyst, we can make methanol. Change the catalyst, we can make jet fuel. Change catalyst, we make gasoline. Change catalyst, we make diesel fuel. And these are drop-in ready fuels. In other words, we don't have to modify engines to use these fuels. So the catalyst is the key component, and fortunately, since the 1920s, catalysts have improved greatly. If tomorrow morning we woke up and said, oh, the world needs to run on ethanol, we stop the presses, swap out the catalyst, and we're back into producing ethanol. There is a process, a Honeywell process, that we can take corn to make ethanol and take that ethanol and make jet fuel. And what we look at is we can take waste coal or garbage to produce a syngas, to produce an ethanol with the catalyst, and we can then use Honeywell's process to make jet fuel. So again, a lot of these are commercial processes out there. Nobody's just seems to have put these together the way we're doing it. I guess we think outside the box, and that's our problem is I can't find the box. So if you say tomorrow, Ian, Bill, we need diesel fuel, we can do it. That makes sense.
That does make sense, but it begs the question, if this is such an inefficient way to produce renewable energy, it sounds like a great way to make hydrogen fuel, to get a hydrogen rail system off the ground. That the hydrogen highway that California has been talking about for at least a decade now sounds like a great way to get that off the ground. How come nobody has put this level of effort into it up until this point?
It costs money, a lot of money. If I buy a hydrogen car today, for example, as you brought that up, I can go to California and I can ride the hydrogen highway. In other words, there's a series of gas stations up and down the state that I could go fuel my car up, but I can't leave California because I can't buy the fuel. Cummins back in 2021 announced that they'd built a hydrogen engine for trains. It got 600 miles per fuel up versus 500. But if I fuel the train up here, where can I refuel it? So we even looked back in 2021 at taking landfills across the country and producing syngas. And out of the syngas, we could pull a hydrogen. And we could build a hydrogen highway across the country, north and south, east and west, using dumps or landfills, or in this case now, waste coal piles. In fact, I was going to a meeting here in Pennsylvania. They were talking about building hydrogen refueling stations from methane and old coal mines. And it wound up getting canceled because everybody's on vacation. But I finally met with that group, Grow Rural PA, and I said, why would anybody want hydrogen here in Pennsylvania? There's no hydrogen cars, there's no hydrogen trucks, no hydrogen trains. Why do you want hydrogen? Well, apparently in a little pocket area of Pennsylvania are groups of companies that produce sintered metal. So they take metal powders, they stamp it, and out comes a part, and they use hydrogen in the process. So much so that when I left there and I was driving back where I was staying at, I passed an Air Liquide truck going the other way with hydrogen in it. So our thinking is go to that area, find a big waste coal pile, take that waste coal pile and produce synthetic fuels, take the excess and pull out the hydrogen, take the acid mine drainage and make hydrogen. So hydrogen to us becomes a byproduct. And the way I look at it is jet fuel pays the bills. Hydrogen becomes sprinkles and cherries on top, or rare earths are sprinkles and cherries on top. If I were, and I've told them this, if I was a hydrogen company, I wouldn't be here. If I was a rare earth company, I wouldn't be here because the minerals are very sparse. But as a jet fuel company or a major power company, that pays for us to do these other things, which then becomes extra profit centers. So another reason nobody's done this is, well, let me say this. There's a family called the Rich family out on the eastern side of PA. They're in the anthracite region. Back many decades ago, they were going to take waste coal, use Sasol for the synthetic fuel division, I believe BP for the gas-fired division. The project was going to cost $1 billion. They were going to produce synthetic jet fuel back then. But see, nobody cared about synthetic fuels back decades ago. Not so much even a few years ago. So the market change has also caused this growing and emerging industry to come up. In fact, Trump signed an executive order just recently to use coal to make clean coal to make power for AI data centers. And literally, the sampling I just had done at this lab, that may be something we do in that pile. The other part is CapEx, cost of equipment. This little pile here in PA, 4 million tons, will take about $170 million to build the plant. Then you have environmental groups to deal with, which fortunately, because our emissions are clean, we won't have the pushback that a power plant would have or a fuel plant would have, because our emissions are clean energy. I mean, it's all forms of energy that come out of this. And the other thing that happens too is there's no more waste coal pile when we leave here. So if you look at a Monongahela, 75 million tons, to build that plant out, to get rid of that pile in 20 years, we're looking at $3 billion. So we're looking at setting up our own fund to start building these sites all across PA and, put it in the front end, get that going, and then bring in debt equity to build out these plants that will sometimes, in some cases, cost billions of dollars. So there's another reason. It's the money.
Thank you for listening to this episode of the Fireside Chat. To offer feedback on this episode or to look for more information about Firepoint Energy, please visit our website at firepoint.energy.